Daniel has one road out. That's not a figure of speech. West Yellowstone, Montana, population 1,300, sits on the edge of the most dangerous volcanic system in North America, and it has exactly one primary road connecting it to anywhere else. Highway 20 West, 2 lanes, the same road everyone else uses to get in. Daniel runs a fly fishing guide service here. 19 years on the Madison River. He knows where the trout hold in late September and where the bison cross in March. He knows this place the way you only know somewhere after nearly 2 decades of choosing to stay. What nobody has ever told Daniel, officially, in writing with a plan attached, is how he is supposed to leave. Not in a hurry, not when the ground is moving, not when 4 million park visitors are on the same road, in the same direction, with the same ash falling on the same engines. There is no evacuation plan for West Yellowstone. There is no evacuation plan for the 4 million people who visit Yellowstone National Park every year. There are committees. There are federal working groups that have been meeting since 2005. There is a proposal from NASA scientists that would cool the magma chamber from below, a serious, peer-reviewed concept that would take 50,000 years to work. The evacuation plan needed for next Tuesday has no timeline at all. This video is not about whether Yellowstone will erupt. It is about what the people responsible for your survival decided to do, and decided not to do, with the 30 years they had to figure it out. Yellowstone is not a volcano. It is a supervolcano, a distinction that exists because the word volcano is not large enough. A standard volcano forms when magma pushes upward and erupts at a central vent. Yellowstone does not have a central vent. It has a caldera, a collapsed basin 40 miles long and 25 miles wide, that formed when the last major eruption, 640,000 years ago, was so catastrophic that the ground above it simply collapsed inward. The magma system beneath it exists in 2 layers. The upper chamber sits between 3 and 9 miles below the surface, not a pool of liquid rock, but a saturated sponge of hot, partially molten material laced with superheated gas. Below that, a second reservoir stretches from 12 to 28 miles down, broader and deeper than the upper chamber, feeding it from below. The last full eruption ejected more than 1,000 cubic kilometers of material. For comparison, the 1980 eruption of Mount St. Helens ejected 1 cubic kilometer. Yellowstone's last event was 1,000 times larger. The ash cloud from a full eruption would reach the Mississippi River within 2 days. It would deposit measurable ash across the entire continental United States. It would lower global temperatures by several degrees for years, disrupting agriculture across the northern hemisphere. Geologists call this a volcanic winter. The annual probability of a full Yellowstone eruption is approximately 1 in 700,000. That is not zero. More importantly, a full eruption is not the only scenario. Yellowstone produces hydrothermal explosions, steam-driven blasts caused when superheated groundwater vaporizes instantly. The last major hydrothermal explosion, 13,800 years ago, left a crater 2 miles wide. These events require no magma movement at all. They can happen with no warning. They have happened before. They will happen again. The Park Service's own literature acknowledges this. The USGS monitors it continuously. What neither organization has done is build a functioning system to move people away from it. Here's the timeline. The public rarely sees in one place. Pay attention to the pattern. 1973, the USGS establishes systematic seismic monitoring at Yellowstone. They confirm a shallow magma chamber beneath the caldera. The finding is published. Noted. Filed. 1984, ground deformation studies show the caldera floor rising and falling by several inches per year. Scientists describe it as the ground breathing. The findings are published. Noted. Filed. 2004. The USGS publishes a comprehensive volcanic hazards assessment. It maps the ashfall zones. It identifies the evacuation corridors. It states clearly that road infrastructure within and around the park is insufficient for rapid mass evacuation. The report lands on the right desks. It is read by the right people. Nothing is built. 2005. FEMA runs planning exercises for Yellowstone eruption scenarios. The exercises conclude that evacuating between 500,000 and 1 million people from the immediate impact zone would require 72 hours minimum, using road infrastructure designed for a fraction of that load. The exercises are documented. The gap is confirmed. Nothing is built. 2014, the largest earthquake swarm in 30 years. More than 200 events over 2 weeks. Magnitude 4.8. Felt across the region. Wyoming's governor requests a federal assessment of evacuation infrastructure. The assessment confirms what the 2004 report already said. Nothing is built. 2017, 2,400 earthquakes over 3 months. The most active seismic sequence in the modern monitoring era. International headlines, congressional briefings. Nothing is built. 2022, USGS upgrades its monitoring infrastructure. Better sensors, better detection, better data flowing into better models. The road out of West Yellowstone is still 2 lanes. The pattern across 50 years of science is not ignorance. It is something more precise than ignorance. It is a system that is very good at documenting the problem and very practiced at not solving it. Here's the part that sounds impossible until you look at the map. West Yellowstone, Montana. 1 road in, 1 road out. Highway 20 West is the primary exit corridor. In normal summer conditions, peak tourist season, full park, Highway 20 handles roughly 5,000 vehicles per day. In a Yellowstone emergency, FEMA's own models estimate 4 million visitors in the broader park region during peak season, plus 400,000 permanent residents in the surrounding counties. The road network serving the Yellowstone Plateau was designed for recreational access, not mass evacuation. It has not been significantly expanded since the 1970s. Transportation engineers use a measurement called clearance time, the number of hours required to move a defined population through available road capacity. The clearance time for a full Yellowstone evacuation, using current infrastructure, under the best-case scenario modeled by federal planners, is not measured in hours. It is measured in days. During which time, if the eruption sequence is progressing, ashfall begins within the first 24 hours. Ashfall at concentrations above ½ inch collapses roofs. It clogs engines. It makes roads impassable. It makes air unbreathable without respiratory protection. Daniel, in West Yellowstone, has 1 road out. By day 2 of an eruption sequence, that road won't be passable. Nobody has built him another one. This is the part the disaster documentaries skip, because the failure here is not dramatic. It is not corrupt. It is bureaucratic in the most precise sense of the word, a series of rational decisions made by rational people inside a system that was designed to defer costs that are certain and distant onto a future that hasn't arrived yet. Expanding road infrastructure around Yellowstone would cost billions. The park sits at the intersection of 3 states, Wyoming, Montana, Idaho, each with its own Department of Transportation, its own budget cycle, its own legislative priorities. Federal coordination would require an act of Congress. The National Park Service does not build highways. FEMA plans for disasters but does not fund pre-disaster infrastructure. The Department of Transportation funds roads but does not prioritize scenarios that have not occurred. Nobody owns the problem, so nobody solved it. Instead, the system produced what systems produce when action is expensive and inaction is invisible. Plans, working groups, hazard assessments, interagency coordination frameworks. A Yellowstone volcano observatory that monitors the caldera in real time and publishes monthly updates that almost nobody reads. In 2014, following the major earthquake swarm, Wyoming's governor requested a federal assessment of evacuation infrastructure. The assessment was conducted. It confirmed what the 2004 USGS report had already established. The road network is inadequate for mass evacuation. The assessment did not result in new roads. It resulted in a recommendation for further study. That study was completed in 2019. It recommended improved signage and a public awareness campaign encouraging visitors to familiarize themselves with evacuation routes. The public awareness campaign has not been widely distributed. Daniel has not seen it. In 2017, NASA scientists at the Jet Propulsion Laboratory published a proposal that made international headlines. The concept? Drill into the outer edges of Yellowstone's magma chamber and pump water through the superheated rock, extracting heat from the system over centuries. By cooling the magma chamber gradually, the proposal argued, it might be possible to reduce the eruption risk over geological timescales. The estimated cost? roughly $3.46 billion. The estimated timeline, 50,000 years. NASA was clear that this was a preliminary concept, not a funded proposal. The agency noted significant technical risks, including the possibility that drilling itself could trigger the eruption it was designed to prevent. The proposal received enormous media coverage. It was cited in hundreds of articles as evidence that science was working on the Yellowstone problem. In the same year, the federal budget for Yellowstone evacuation planning was not meaningfully increased. This is the architecture of inaction at its most precise. A 50,000-year solution for a problem that could arrive next Tuesday, funded with headlines instead of dollars, while the road out of West Yellowstone remains exactly as wide as it was in 1972. The NASA plan does nothing for Daniel. It is a plan for a version of Earth that Daniel's descendants' will never live to see. One more thing the coverage always leaves out. You don't have to be at Yellowstone to be in danger. Volcanic ash is not soft. It is not the gray powder from a fireplace. It is pulverized rock, microscopic shards of glass and silica that shred lung tissue on contact, clog engines within minutes, collapse roofs under its weight, and turn roads into surfaces no vehicle can navigate. A half-inch of ashfall, the threshold for roof collapse risk, can reach 500 miles from the eruption point within 24 hours. Picture Salt Lake City going dark, Boise losing power, Billings under an inch of glass dust by Tuesday morning. 3 million people in the immediate ashfall zone reaching for the masks they don't own, trying to start the cars that won't run, calling 911 on towers that have already gone down. The federal stockpile of P-100 respirators pre-positioned in those cities is not sufficient to protect 10% of that population. Daniel is 200 miles from the caldera. He does not own a respirator. Nobody told him he needed one. The people who made these decisions were not negligent in the way that word usually implies. The USGS scientists who mapped the hazard zones did their jobs with precision. The FEMA planners who ran the evacuation scenarios ran them honestly. The federal working groups that identified the infrastructure gaps identified them correctly. The failure is structural. It lives in the space between knowing and funding, between the report that lands on the desk and the budget line that never appears. Every year that Yellowstone doesn't erupt is a year that the decision to defer infrastructure investment looks correct. The math always holds until it doesn't. And when it doesn't, the gap between what was needed and what was built becomes visible in a way that no report and no working group can paper over. Cascadia is a fault line that science found, governments acknowledged, and political systems chose to manage at the pace of budget cycles instead of geology. Yellowstone is the same story with one additional chapter. The plan that exists is not a plan. It is a document that describes in careful technical language why the plan cannot be built with the resources currently allocated to building it. Daniel runs his fishing guide business in West Yellowstone. He takes visitors out onto the Madison River. He shows them where the trout hold in the current and where the osprey nest in the cottonwoods along the bank. He is 19 years into a life built in a place that has one road out. Nobody told him that when he moved here. Nobody has told him since. There is something practical that comes out of everything this video has described. The gap in Yellowstone preparedness is not primarily about eruption probability. It is about ashfall. A hydrothermal explosion, the more probable lower threshold event, produces localized but intense ash and particulate fall with little or no warning. A partial eruption produces regional ashfall within hours. A full event produces continental ashfall within days. In every scenario, the first thing that kills people who are not in the immediate blast zone is what they breathe. Respiratory protection rated for volcanic ash, a P-100 or equivalent respirator, is not standard household equipment. Most emergency kits don't include it. Most people who live within the ashfall zone of a major volcanic event don't own one. The link in the description is a P-100 respirator rated for fine particulate, built for exactly the scenario this video describes. It's available on Amazon. The link is an affiliate link that costs you nothing extra and keeps this channel running. The ash doesn't care if you're ready, but the difference between having that respirator and not having it in the first hours of an event is not a small difference. Link is in description. Yellowstone is a supervolcano that the government mapped, monitored, and chose not to prepare for at the pace the science demanded. The next video is about a fault line most Americans have never heard of, one that doesn't run along a coast, doesn't sit beneath a national park, and isn't attached to any of the geological threats that get the headlines. It runs beneath the middle of the country, beneath the Mississippi River, beneath the bridges and pipelines and power lines that connect the eastern United States to everything west of it. In 1811, it produced a series of earthquakes so powerful that the Mississippi River ran backward for 3 days. The infrastructure built above it since then has never been designed to survive what it did then. That video is next. Subscribe. 640,000 years ago, there was nobody here to make a decision. The caldera formed. The ash fell across a continent. The sky went dark for years. And the world continued without anyone having failed anyone, because there was no one yet to fail. That's not the situation now. Now there are sensors in the ground and satellites overhead, and scientists who publish monthly updates, and federal agencies with emergency management mandates and 50 years of documented evidence sitting in filing cabinets in Washington and Cheyenne and Helena. Now there is Daniel, 19 on the Madison River, 1 road out. The magma chamber beneath him has been mapped more precisely than almost any geological feature on Earth. We know its shape. We know its temperature. We know the history of what it has done every few 100,000 years since the North American continent took its current form. We know what we haven't built. We've known for a long time. I think about Daniel sometimes, not because his situation is unique, but because it isn't. There are people like him inside every radius of every threat this channel has covered. People who built a life somewhere real, somewhere they chose, somewhere that the maps say is beautiful and the reports say is borrowed time. They didn't get a vote on the decision to study instead of build. They didn't get a plan. They got the road.